In this example, ladies and gentlemen, what we're going to be looking at, Chelsea, is again now we're getting into ones that are a little bit more complicated. All right, and this is basically the type of problems that I was trying to do the warm up to help prepare you guys for, is getting to ones where we're now going to have to do a little bit of work. And basically, when we're adding and subtracting, just like when we were multiplying and dividing, the first thing we always want to do is simplify. All right, we don't want to be trying to identify the leading or the LCD. Oops, wrong LCD. If when we do not have a simplified rational expression. So the first thing we're going to do is simplify. Now, unfortunately for here, we only have one fraction we need to simplify because 4 over 7x cannot be simplified. So I have 4 over 7x. Done. In this one, though, we have 3x squared plus x minus 5. I can simplify that. So I can go ahead and use my diamond. I can do 3 times 5 is negative 15. Add to give you 1. And 3 times negative 5x, add to give you 1. Well, that's not going to give me anything. That is usually not factorable. Double check I have the right answer, right? Oh, OK. So however, over here, I can factor out a 7 in this case. So I can factor out a 14x plus 21. I can factor out a 7 into giving me x plus 3. Huh? 2x plus 3. Thank you. Does everybody follow me? OK. So I can't factor the numerator, as I showed you. Do you guys? I should maybe keep that up there. 3 times 5 is negative 15 and positive 1. There's no two numbers that I'm aware of that multiply to give you negative 15, add to give you 1, right? So therefore, it's just non-factorable. You can't factor it. So we're going to leave that as is. 3x squared plus x minus 5 divided by 7 times 2x plus 3. So now we look at this and we say, all right, so what is our least common denominator? Well, we know that they both are going to share. And basically, what our least common denominator is going to be if we were to kind of multiply them. But you don't need to multiply 7 times 7, because we know that they both divide into 7, right? These would both divide into the 7. So my least common denominator is going to include 7. It has to also have an x. And it has to have a 2x plus 3. So it's basically the product of both of my denominators, except I'm not really multiplying the 7 times 7 because both 7 and 7 divide into 7. We don't need to say that they divide into 49 because they already divide into each other. So now, if that's my least common denominator, I need to multiply each one to get to our simplified polynomial. So I multiply this side by x over x. And then over here, I'll multiply by, I'll multiply by 2x plus 3. Does everybody follow me with finding the least common denominator? So now apply your distributive property. OK, and what I get over here is 8x plus 12 divided by, I'll call this 7x times 2x plus 3, minus, I'm going to put this in parentheses still here. This would be 3x cubed plus x squared minus 5x, all over 7x times 2x plus 3. OK. Now I need to make sure I distribute my negative sign, right? Because you're subtracting this whole thing. So when I distribute the negative sign, what I do is, remember, I change the sign of each one. So now I turn this into an addition problem. And I change the sign of each one. So now I just combine like terms. So now they both have common denominators. I can just combine like terms. And I'll write this in descending order. So I'll start with my highest exponent first, which is negative 3x cubed. Is there any other cubes? No. So I'll write negative 3x cubed. Then I go to my squares. I don't have any other squared terms. So I'll write negative x squared. However, my x's, I do have two x's. I have 8x and 5x, which is going to give me 13x. And then I have a constant of 12. And then, ladies and gentlemen, this is all over 7x times 2x plus 3. That's supposed to be another parenthesis. And we can't really factor anything else out from there.